Welcome to the review recording 1DEF, which accompanies instructional recordings 1D, 1E, and 1F for Unit 2, Chapter 2 of Mathematics 2200. We'll look at, given a trigonometric ratio for an angle in standard position, find other ratios, finding trigonometric ratios for quadrantal angles, and given a trigonometric ratio for an angle in standard position, find the possible measures of that angle. In example 1, we're asked, given cosine of theta equals 5/8, which is a possible value of sine theta? We begin by sketching a set of axes. Since our cosine is positive, thinking about cast, our terminal arms can be in either quadrant 1 or quadrant number 4. So we have two identical triangles, one in each quadrant. This side is 5. Remember, cosine is x over r. So the x side is 5. The r value is 8 for each triangle. So we have to figure out the y value. So we have 5 squared plus y squared equals 8 squared. That gives us 25 plus y squared equals 64. Subtracting 25 from both sides, we've got y squared equals 39. Now we have to be a little careful here because y will equal the square root of 39 if it's in the first quadrant, but it will equal the negative square root of 39 if it's in the fourth quadrant. So in other words, y could equal plus or minus root of 39 depending on the quadrant that we are in. We have to find the possible value of sine theta. In quadrant 1, sine theta is equal to root 39 over 8. That's not one of the given possibilities in our options here, so we look for the other one. Sine theta equals negative root 39 over 8. A is a correct answer. Example 2. For which angles in standard position is tan theta undefined where theta lies between 0 and 360 degrees? All my options here involve quadrantal angles. The quadrantal angles are 0, 90, 180, 270, and back to 360. Now recall the radius of the unit circle is always 1 unit. So the coordinates at 0 degrees are 1 and 0. Tan of 0 degrees, remember tan of an angle, tan theta, is your y value over your x value. Our y value is 0, x value is 1, that's equal to 0, that's not undefined, that's good. Let's go to 180 degrees. Coordinates down here are at negative 1, 0. The tan of 180 degrees is equal to 0 over negative 1, which is 0. That's good, no problem there. Now down here, 0 and negative 1 would be the coordinates. Cosine of 270. That's your x value over your r value. Well, that's only 0 over 1 because the radius, don't forget, is 1. So that's okay, that's not undefined. Tan of 270, y over x, negative 1 over 0. That's undefined because you cannot have division by 0. So D is the correct answer here. In this last example, we're told that the tan of theta is equal to negative 4/7. Theta is in standard position. We have to find all possible values of theta to the nearest tenth of a degree. And we have to state the values of cosine theta for each angle we find. Always working between 0 and 360. Now, because the tan of our angle is negative, we'll use cast to determine that our possible quadrants are in the second and in the fourth. Those are the two places where tan could be negative. We know that both of those angles will have the same reference angle. That's the only thing we can find reliably. So we have tan of our reference angle is equal to 4/7. We use our calculators. do inverse tan of 4/7. Notice I'm using the positive 4/7, not the negative, to get the reference. Inverse tan of 4/7 works out to be approximately 29.7 degrees. So we've got the reference angle 29.7 for both cases. Now in quadrant 2, therefore, our angle would be 180 minus the reference. So it's 180 subtract 29.7 degrees, which works out to 150.3 degrees, approximately, of course. Now in quadrant 4, our angle is equal to 360 minus the reference. So we have 360 minus 29.7 degrees, which works out to 330.3 degrees. Now we still have to find the cosine for each angle. So we construct our reference triangles. Tan is the y coordinate over the x, so the y and the x are 4 and 7 in each case. We keep in mind, though, which values are negative. Negative 7 in quadrant 2. Negative 4 in quadrant 4. Doesn't matter which one I use the Pythagorean theorem on, so I'll do that now. 4 squared plus negative 7 squared equals our r squared. So that gives us r squared is equal to 65, and therefore root of 65 is equal to r. So we mark those on our diagram, and therefore in quadrant number 2, cosine of our angle is negative 7 over root 65, like so. And in quadrant number 4, it's x over r is positive 7 over root 65. To conclude, if you're given a trigonometric ratio for any angle of rotation, other ratios can be found by setting up a reference triangle and using the Pythagorean theorem. Trig ratios for quadrantal angles, you should use a unit circle. And if you are given a trigonometric ratio, use CAST to find possible quadrants for the terminal arm, then find your reference angle, and then use that to find the standard position angles for each quadrant.